Okay, good evening. Welcome to
MinuteMath113.
MinuteMath113. We are going back to the Mathematical Association of America's MinuteMath problems. Yesterday we did a cool geometry problem that was different, and today we got another geometry problem. Unfortunately, we don't know too much about geometry, right?
Yeah.
But we'll get through this one. Okay, you ready? An isosceles right triangle encloses a semicircle. So let's talk what that is. What is an isosceles right triangle? What does that mean?
It means it's got a right angle here.
Right angle there, okay.
And these angles are the same.
And those angles are the same.
The sides.
And the two sides are the same. Okay, great. Encloses a semicircle of area 2 pi. Okay, what does a semicircle mean?
A semicircle is just half a circle.
Half a circle, very good. The circle has its center on the hypotenuse, so the center is, let's say, here. Should have drawn it. And is tangent to both sides. Do you know what tangent means? Tangent means it just touches in one little point there. Yeah, just touches in one point the side of the square. So it doesn't, in other words, it doesn't cross over like this. It doesn't go and touch in a couple different points. It just touches in one point. Okay. Okay, so the question is, what's the area of the triangle? So we have the semicircle that has an area of 2 pi. We have this isosceles right triangle. And we know that. And then on top of all this, us not knowing a lot about geometry, only 20% of the people doing the test got this one right. So
Yeah.
it's a tough problem. What do you think when you look at this problem, out of just curiosity?
Well, we're gonna need to know the side lengths.
Okay, why would knowing the side lengths help?
Well, the area of a triangle is 1/2 base times height.
Okay, so that's one important thing. The area of the triangle. Back up a little. 1/2 base times height. Sorry, that's a terrible 2. 1/2 base times height. Okay, so it'd be great to know the area of the triangle, the side length of the triangle. Anything else would be kind of good to know?
Maybe the area of the entire circle.
Okay, the area of the entire circle. Okay, so if we had a full circle, I can draw that. And if we had a full circle, what would we know the area of a full circle is?
This is it's 4 pi.
The area of the full circle would be 4 pi. Sorry, I didn't do a very good job of that circle.
Looks like an egg.
Okay, the area of the circle would be 4 pi. Why would having a full circle help us?
Well, it might be a little easier, and also we can draw in that.
You're drawing the square, okay, and then actually we would have it should look the same on both sides,
So
right?
it's symmetric.
Yeah, it should look symmetric, so tangent there and tangent there. That's interesting. What can you tell me about the circle? Can you learn anything from the fact that that circle has area of 4 pi?
Well, these sides are 2 pi. And actually this to this is the diameter.
That's true. That to that is a diameter.
But this to this is the radius.
That's the radius. Do you see anything else that looks like it might be a diameter and might be really useful for us?
If you cut the square in half.
Ah, very interesting. Okay. Now, can we figure out what the diameter is, or the radius of the circle?
Well, an area of a circle is 2 pi r. It's 2 pi times the radius.
You sure?
The circumference of a circle
That's the circumference. What's the area of a circle?
is pi r squared.
There you go. So the area of a circle, back up a little, of a circle is pi r squared. So if that area is 4 pi, what's the radius?
You have to reverse this.
That's right. So we would say 4 pi equals pi r squared. Can you solve that?
Well, you can divide by pi, and you
Okay.
get 4 is the radius squared, so the radius is 2.
Radius is 2. Okay, awesome.
Means
Good
the
job.
diameter is 4.
Radius equals 2 implies the diameter equals 4. What does that tell us? That the diameter is 4.
That tells us that the side length is 4.
That tells us that the side length is 4. So what's the area of our triangle?
The area of the square is 16, and you cut it in half, it's 8.
Good job. Good job. Hey, that's a real nice job. And when we eventually study geometry in a couple of years, you're going to learn about this kind of stuff. But there's some great problem solving in this problem. It was hard when it was just half, right? So make it whole, because you know about circles. You know about squares. Okay? So that let us to say, hey, if we can only figure out the radius, we would know the diameter, and the diameter is equal to the side of the square. Pretty cool.
Yeah.
Good job. That's 2 tough geometry problems in the last 2 days. You've done a great job on this video. Good problem solving. Good job.